Recording in progress.
Yeah, comes on everyone. Let's start off. The last thing that we did was the rate of change. Next thing is integration. This would be the most important one. Yeah, even differentiation is important, but this is one thing. So what is this integration again? Again, the same story. Think of like this. In school, right, we studied this way. If a force of, let's say, 10 newtons is acting on a system, and if it moves at distance of 2 meters, what is the work done? Force into displacement, which is 10 into 2. So you got directly 20 joules and you're done, isn't it? Others, you need to keep your cams on or else you'll be removed from the classroom. Right? So that was straightforward, at first 20 joules. But what if someone tells you like this? You have a force here, which is depending on x, and it is going from x is equal to 0 to x is equal to 2. So look at this force. What this force is saying is, let's say it is going from x is equal to 1 to 2. So when x is equal to 1, the force was 1 Newton. So the moment the block goes from here to here, little forward, x becomes 1.1, the force becomes 1.1. If you go to 1.2, force becomes 1.2. You're getting what is happening? Every instant as the block keeps going forward, the force is also changing with x. Now, when I say work done is force into displacement, chalo, displacement I know is 2 minus 1. But what will I take force as? The force ka value is changing from 1 to 2 continuously. Will I take 1 as the force? Will I take 2? Will I take 1.5? How much should I take? You're getting the problem? If the force was constant, your life was easy. You simply take force into displacement. But your force itself is changing at every point. Then how will you take the force exactly? Like how much will you take? So we started encountering these kind of issues, and that is why we need integration to handle such kind of variable stuff. So let's start with something easy, which we know, and from there we will take it ahead. So consider a rectangle. So y and x coordinate. So if you have a rectangle, let the rectangle go from x1 to x2 and let the height of the rectangle be y. So this area of this rectangle is simply y into length into breadth, which is x2 minus x1, which is y into delta x. So delta x is x2 minus x1. Standard, right? This is the area of a rectangle. Now, if you try to do the same thing for a curve, this is what I was saying. Every time you won't be so lucky to get a rectangle. What if you give me some random curve like this? And now you ask me to find the area. Now the problem is, if again, remember the only formula I know is length into breadth. So the area under the curve. So if I try to use the formula y into delta x, the question comes, what is y exactly? It is changing at every point. So how much should I take? You get anything? So actually, we don't know the value of y. Is this making sense? I can't take a single value of y and I can't multiply y into delta x and I can't get an answer here. So we are stuck here. So this is the idea that we go with. So instead of taking the whole thing, we will take very small slices. So we choose very small pieces where we can assume y is almost constant. That means so when you took this random curve, so the suggestion is this. We will take a very small delta x, thin rectangles. This will be delta x. And let this height be y1. Here we'll take a very thin rectangle. We'll take the same width delta x, but the height is y2. And we'll take one more here. This is y3 and so on. So I will divide the whole thing into thin rectangles. Now, if I take this rectangle, it would kind of look like this. This would be delta x and this will be some y, but we still have a problem. If you see, this part will be the error. If I try to use the area of this rectangle, so the area of this thin strip will be length into breadth, which is y into delta x. Making sense? But there is still an error. So here y is the y coordinate of that nth strip. So the y coordinate is changing. It is not constant. Getting it? So I'll just call it yn. So yn is the y coordinate of the nth strip. So if you divide the whole thing into multiple strips, I can call this thing yn, y1, y2, so on till yn. But if you see, there is still an error. This is not a proper answer there. There is still an error. So what we do, what if you make it, so if I add all this stuff, if I can make the delta x very small, do you agree the error becomes very small? So in order to make this, so if you try to add all these parts, the total area under the curve, so let me write like this. So let this strip be delta ai, which is nothing but y coordinate yi into delta x. So if this is delta x, and let this height be yi. So if I add everything, again, this is just explanation. Don't worry too much about it. Just get the basic understanding about it. Sigma, if I add all these areas, so all the strips where the x coordinate will go from xi to x is equal to x2 to x1. Or you can say x initial to x final. So you're starting from here. This is your initial coordinate x1 and this is your final coordinate x2. Do you guys remember summation? Sigma. So if you add all these strips, I will get area under the curve, but there is a problem. This has an error. This is not the exact answer. So this sigma ka symbol is called summation. I hope know this thing. You just add everything. So now how to reduce this error? If this delta x tends to 0, if you make the strip thinner and thinner and thinner, now see when the strip is big, you have a big error. If the strip becomes thinner, error is small. If the strip becomes even thin, the error becomes negligible. So if you keep the thickness of the strip very small, the error also will tend to 0. You're getting it? If the thickness becomes very small, then the error also becomes very small. You're getting this? So then we can say the area under the curve would be limit if you remember, I did something like this in integral differentiation also. Delta x tends to 0, sigma x is equal to x1 to x is equal to x2 delta ai. This is the right answer. Again, see, if I just write this term now, without sigma, without this limit, if I don't write this is wrong. There is an error. But the moment I add this word delta x tends to 0, you're suddenly saying I'm taking very, very thin strips. So error is almost negligible. So this actually gives you the right area. You get the meaning of that? But who will write such a big term every time, isn't it? So what we do, Arya, are you there? Can you switch on your cam? So limit delta x tends to 0, sigma delta ai. So limits will go from x1 to x2. Since we are lazy to write this every time, this whole term here, right, we will shift it into including the delta there. We write this thing. This is a symbol. This looks like a snake ka symbol. So it becomes integral dai, where the limits go from x1 to x2. This is called a lower limit, meaning the point where you're starting from. This is your upper limit, up to where? This is nothing but integral y dx. Now, this symbol, right? This is also meaning of summation only. Sigma means summation. So logically speaking, this is the symbol for integral. It's called integral, that snake ka symbol. Getting it? So this is also summation, but summation of small pieces. If you add very, very small pieces, we have to use integration. How small? We are talking about 0.0000, something like 10, 15 zeros. Do you guys remember in differentiation, where delta means big change, d means very small change? Is this clear, everyone? So if delta x is very small, we call it dx. So this is how the function looks like. And we know y is equal to fx. So for a function, so the area under the curve, again, we are just lazy to write that limit delta x tends to 0, sigma x1, x2. We simply put integral and it is understood. You're talking about a very small pieces. So area under the curve is given by integral f of x dx x1 to x2. That is the meaning. We will see how to write that thing. What will be the results for that? Again, no one is going to ask you this in the exam in physics, but did you guys get the meaning of what we tried to do? We started the whole story with this. I know area of a rectangle, length into breadth. The moment you give me a curve and you're asking me to find the area, I have no clue how to do this because the height is changing everywhere. So we came up with an idea. I will take very small slices such that each slice ka rectangle, it will become like a rectangle, but there is a problem. We always get some error on the top. So to reduce that error, we said that delta x become very, very small. Then the strip is so thin, you can assume almost, the error is negligible. Then the area under the curve becomes limit delta x tends to 0. So the meaning of limit is you're taking thin strips. That is the meaning of it. But we don't want to write that every time. So we replace that entire symbol with one thing called an integral symbol. So this is how you read this. Integral f of x dx, meaning when you go from x1 to x2, the curve f of x, the area under the curve f of x is this much. Clear with this? So just understand that. Don't worry too much about it. And let max people handle this in more detailed. They will teach you what are limits and everything. But did you get a meaning of it? You saw how from a rectangle I got area under the curve. And if you remember, we did something like that in differentiation also. From a straight line, we got the slope of a tangent, isn't it? There also we did something like that. You brought the 2 points closer and closer and closer. At some point that AB became a tangent. Okay. Now this differentiation, right? If you look at this function, so this is one important thing. This is the basis of whole thing. If you take an integral And if you differentiate it, look at this. Integration means adding the function, differentiating, you're breaking it, you get the function back. So that is one important thing. So when we differentiate an integral, we get the function back. So both are opposite to each other. Unlike, differentiation, we don't have chain rule and everything. So in that sense, the integration ka formulas are straightforward. And we will not do extensively also. Even in max, right, integration is more tougher than differentiation. Integration, you have pretty deadly stuff in max. But we will see only the things required for physics. So you can note down this stuff, what I'm writing now. So these are the formulas we will need. We will not go into the discussion how we got the formulas. So I'll give you a function. And if I integrate the function, we'll see what is the result. And be very careful. There is a high chance you will mix up differentiation integration ka formulas. People do that. Even I did that once. In one batch, I was teaching integration. Second batch, I was teaching differentiation. This was long back, 2011 or something, when I started my career. So I got confused. In one batch, I told the differentiation formulas. When I was teaching integration, after 10 minutes, I was thinking something is looking weird. And then I had to cancel the whole thing and start again. From then, I decided I never teach integration and differentiation at the same time, which I don't do even till today. So be very careful with that. People do goof up. So first thing, see, f of x. So if your function is x power n, this is for n not equal to -1. So integral x power n dx, the formula is given by x power n plus 1 by n plus 1. So listen carefully, one or two formulas if you need to get it. This kind of an integration is called indefinite integration. What is the meaning of this? The problem is, did you notice something? I didn't give you the limits. Means you found area under the curve, but you didn't tell me you want area from where to where. So the limits are not given. So if the limits are not given, such an integration is called indefinite integration. So the limits are not given. So that is, we don't know the starting and the end points.
Sir,
Yeah.
so is this the area of the entire graph under the curve?
X power n dx, no, it's not the area under. You didn't tell me anything. So there's a plus constant here. That will take care of how much is that.
So
You
what is
tell me from
this?
where to where. This is area under the curve.
No, but if we have not defined a starting point and an end point, then
So you give me the starting point and end point, I'll give you the area.
oh, so the constant will tell you the area.
Tell you that
It
thing,
will
yeah.
decide.
Yeah. So we don't know the starting and the ending point. So that is the reason we keep this plus constant. Because I don't know what is your starting and ending point. It could be anything. So if you give me the starting and ending point, the constant ka value will come out something.
So is that
Again,
also why, like, if we differentiate, the constant goes away? So if we integrate,
goes
the
away. So
constant
that
comes.
also works. Yeah. So if someone doesn't give you limits, you have to call it indefinite integration. Now listen to this thing. Remember, just now I told you, if you integrate the function, you'll get the function back. So if I differentiate, if you differentiate a integral, you'll get the function back. If you differentiate x power n plus 1 by n plus 1, you will get n plus constant. So you're differentiating the whole thing. This will become 1 by n plus 1 into n plus 1 into x power n plus 1 minus 1, and constant is 0. You'll get x power n back. Is this making sense? So if I differentiate this, I will get x power n back. Clear with this? So that constant won't matter. Whenever you differentiate, it will become 0. So this is what I was saying. If you differentiate an integral, you'll get the function back. So there's a pretty neat way to figure out the answer then. So, indirectly what I'm asking, f of x, integral f of x dx, think of like this. So the question is this: suppose if I want sin x here, ask yourself, what should I differentiate here to get sin x here? Isn't that the question now? Whatever answer I get here, if I differentiate, I should get sin x. So what should be the answer here so that when I differentiate, I'll get sin x?
Minus cos
Minus
x.
cos x.
So if you take only cos x, cos ka differential is minus, right? So if you put a minus here, so now if you differentiate minus cos x, I will get minus of minus sin x, I'll get sin x back. You're getting it? That is one way to remember. So, but anyways, let's see that. But have a look at this. You can put on this part. X power n plus 1 by n plus 1. I think I'll give you a better formula than this in the next page. This we will not use that frequently. It comes little rare in physics, indefinite, but it does come. We will use definite integration most of the time. Then we call something a definite integration, say. Same thing, integral x power n dx x1 to x2. I'll give you some examples what it means. Now, did you see here? I gave you the limits. I told you want area from where to where. So this you're asking, find the area under the curve x power n from x1 to x2. If limits are given, such a thing is called a definite integration. Again, the formula is still the same. What is the formula for x power n? So listen carefully here. So x power n plus 1 by n plus 1 formula is done. Then we put a straight line here, x1 to x2. The meaning of this thing is the integration is done. If n is equal to minus 1, denominator will get 0 record. Right? So x1 to x2. So this is how we pronounce it. The meaning of the straight line is integration is over. We still have to put limits. Integration is over, limits are still pending. So think of like this. So if you first, what you do now, so x2 is final, x1 is initial. So put x2, x2, n plus 1 by n plus 1. Then put x1, x1, n plus 1 by n plus 1, minus sign. So look at the meaning of this. When I put x2, I got area up to x2. You didn't tell me where you started from. When you put x1, you got area up to x1. Now tell me, if I subtract area from x1 to x2, what do I get? I get area between x1 and x2, isn't it? Are you getting the meaning of this? Again, see, this is the process. First you integrate, then you put a straight line. The straight line meaning integration is over, you have to keep the limits. How do you put the limits? Put the upper limit x2 first, then put x1 and then subtract them. So let me give an example.
So what about the constant?
There is no constant. There's a definite integration. I know the limits.
So I mean like the constant will come and just cancel off.
You can say like that, but we don't use it. Don't worry about that, Ray. We're not a max class. Don't worry about that part. Keep it simple. These are mathematical tools. Just remember, lad, max people teach you for 2 months. Now listen to this thing. Suppose if you have a curve y is equal to f of x is equal to, let me show it in the next page, but you can put it down. Put it down. This is the most important one. This x power n dx, right? In physics, mein integrations, mein this will be at least 60-70% integration is this only. Maximum integrations, this is the thing which will integrate 60 to 70% of the time. Clear with this? Let's say. So example, let's say I have a function y is equal to f of x is equal to x square. And you ask me to find integral f of x dx. Now remember this, f of x is the length, dx is the breadth. This is the area of the thin rectangle. Integral meaning area of sum of all those rectangles. Are you getting it? So you just can't write integral f of x. This is a meaningless statement. dx hona chahiye. There should be a dx beside it. And let's say, example, I'm giving you limits from 1 to 2. You know, what did I ask you right now? So basically we have a curve, y is equal to x square. So y is equal to x square looks like this. How do you know that? Just put the values. X is equal to 0, 0. X is equal to 1, y is equal to 1. X is equal to 2, y is equal to 4, and so on. Similarly, x is minus 1, 1. X is minus 2, 4. So this is how the curve looks. It's a parabola, y is equal to x square. And what am I asking you? Find the area from 1 to 2. Meaning somewhere here is x is equal to 1 and somewhere here is x is equal to 2. I am asking you to find this area. That is the meaning of that statement, integral f of x dx here. Now look at the formula here, integral x square dx 1 to 2. This thing is looking like x power n, so n is 2. The formula is x power n plus 1 by n plus 1. Integration is over, limits are 1 to 2. So this is x cubed by 3. Limits are 1 to 2. So substitute 2 there, 2 cubed by 3. Substitute 1 there, 1 cubed by 3, and then subtract them. That will be 2 cubed minus 1, 8 minus 1, 7 by 3. So that green ka area is 7 by 3. Did you see? Till now, we didn't have a technique to find area under the curves, isn't it? Now we know. Now, how we got that formula, let's not bother about it. But there, that x power n gives you area under the curve. Is everyone clear with the example? Any doubts on this, please ask me. So if I give you limits, means I know you want area from way to way. Such a thing is called definite integration. So you won't get constant there. Like Arya was saying, you can also argue like that. The constants will cancel out on both the sides. Yeah, kind of makes sense. All clear with this?
Sir,
Any doubts, Trish? Advay.
Sir, when you substituted only the top part, or let's say only the upper limits get substituted from x, right?
Both, na. You substituted 2 here, substituted 1 here, and then subtract both the values. 2 cubed by 3, 1 cubed by 3, then subtract them.
Okay, sir.
No, you have to substitute both of them and then subtract from upper minus lower.
Yes.
Sure. So this is your first formula, x power n. The second one, integral sine ax plus b dx. So I'm just writing the more generalized ones. Limits are from x1 to x2. I'm giving the limits. So this will be minus 1 by a. You need to mug up these things now. Cos ax plus b. Integration is over. Limits are x1 to x2. So if I substitute the values, this will be cos of. So first put x2, ax2 plus b. Then substitute x1, cos ax1 plus b, and then subtract them. That is the answer for this.
Sir, could you
So if I
explain the integration part here?
There's nothing to explain. You need to remember this.
Oh,
You're asking how did I get that, right?
Yeah.
We are not going to do that.
Okay.
For this, that is a formula. You have to remember that. So whenever you integrate sine ax plus b, we are going to get minus 1 by cos x plus b. If you want only an explanation, the only thing I can give you is, if I differentiate this, I'm going to get sine ax plus b. No?
Yeah. All right.
Cos ax plus b will be sine ax plus b. Then I use chain rule, when a will come out, that a and this a will cancel. You will get sine ax plus b.
Understood, sir.
But we're not going to get into the part how we got this. We're not going to do that.
so is there like a chain rule or something?
No, there is no chain rule in this. You're saved.
So we just check manually what integration.
That is only in physics. Actual max mein you will die. You can't do that. So what I'm teaching you, right, integration right now, think of like this thing. It's a small puppy which got lost on a road. Max May, they will teach you a Godzilla roaming around and destroying buildings and bridges and everything. It's a disaster getting it. I hated that integration there. Yeah, it was very hard. Matlab, even till today, people find integration tough. It's very tough actually, meaning certain parts go over the head. Differentiation is actually much easier. You can always differentiate something. You will
Symbols
learn
से
next year.
overwhelming दिखते हैं sir.
Where
Symbols overwhelming
you
दिखते हैं.
will get used to it. This is nothing, right? When you go to engineering first year, right? We had courses where we didn't see a single number for weeks. The only number we saw was question ka number. So it will be different. Next thing. Cos x plus b. So you need to mug up these results. Huh? We're not going to see like how we got them. Let max people handle it next year. So cos x ka integral will be sin ax plus b. So integration is over. So the moment you put a straight line, meaning integration is done, we have to substitute the limits 1 by a. So first put x2, sin ax2 plus b, then put x1. There. Write it down. You will remember that way better. I'll show you 1 or 2 examples on this. Again, did you notice something in differentiation, right? The actual differentiation was easy, right? The headache was converting a problem into differentiation when we did applications, maxima, minima, and all that. Physics, that was always the headache. It's not the max part. Converting a verbal problem into this is always the headache. All copied? Turn in the page. Let me show an example. Let's say if someone gives you like this, integral sin x dx from 0 to 90. Now look at the formula here. So the formula here was sin ax plus b, isn't it? So here a is 1 and b is 0. So what was the result for this? Minus 1 by a cos ax plus b. Limits are from 0 to 90. So a ka place mein you have 1 and b ka place mein you have 0. So this is minus cos x 0 to 90. So substitute the values, cos 90, then substitute 0, cos 0, and subtract that. Cos 90 is 0, and that is 1. So what do we got here exactly? So if you actually plot this graph, y is equal to sin x. This is how the sine graph looks like. This is the sine graph. So at 0, you're here. At 90, this is the peak value. So I'm asking you to find the area under the sine from here to here. So this shaded area is 1. Did you see what we found out? So you found the area under the sine ka curve. That is the meaning of this. Under the sine ka graph, find the area from 0 to 90 degrees. Sure with this? In case you're wondering, let me just show you. So the general formula was this: sin ax plus b dx. So if you compare this, you have a ka place mein 1 and b ka place mein 0. Put it in the formula and you're done. All sure with this? Pratyasha? Devanshi, clear with this? Shaunak, Advait? Advait, adjust your camera a bit. I can't see you. Utsa, you also please adjust your camera a bit. Make sure your faces are completely visible on the screen so that we are sure you're not eating any secretly some cake or something. Next thing. Yeah, there's one of your senior used to be there. He used to sit with the popcorn. Yeah, this is not a movie karke. He's like, sir, maza aa raha hai. And that guy was different though. He did got a rank of around 2,300 or something. He used to solve the questions and eat. Next thing. Integral e power ax dx. So this is 1 by a e power ax. Integration is over. Limits are x1 to x2. 1 by a, put the limits e power a x2, then put x1, e power a x1 and subtract them. This is the area under the curve. 1 by ax plus b dx. This is one important integration, right? You will see this is a little less in 11th, but 12th, literally everywhere it keeps popping up. This is the fifth one. This is 1 by a ln ax plus b. Whenever it comes, I'll show you. x1 to x2. Put the limits ln ax2 plus b minus ln ax1 plus b and subtract them. And the most common one is this integral dx by x. This one, Ray. Oh yeah, n is equal to -1 is this guy. So for n is equal to -1, you can't use that x power n ka formula. We have to use log. So this will become ln x.
सर पर x के n के बाकी वैल्यूज के लिए चलता है ना
It works. Only for n-1 we don't use it.
सर ऐसा क्यों
Because we are getting n plus 1 in the denominator now. You are getting 1 by 0 there.
Yeah, but then it should be not defined, right? How long करके आता है
That function is not defined for that. dx by x curve कैसा दिखेगा पता है? If you put x is equal to 0, value कितना होगा? Infinity होगा. So you can't find area under this gap, right? This will never touch only that point. There is no left-hand limit. You will get closer and closer, but you'll never touch the left-hand side. So we'll not get into that. So that's a different thing. There, these are the main 5 formulas that we use. X power n, sin ax by cos ax plus b, e power ax, and 1 by x plus b. Now, if you know this much 5, I think you can handle most of them. And we have 2 identities. Luckily, we don't have division rule in integration. We have product rule, but we don't need in physics. So we only have 2 simple things. Let me show you them also. You can put down these things.
So
So the
could you
ending
go
of
back to the last page for 1 second? Previous one. Yeah, that one. Okay, yeah, we can move forward.
So this ending of integration will be the beginning of kinematics. So as we're ending this chapter, we will go ahead with the kinematics also. The next thing, we have 2 identities. The first one, if you have a constant into a function, right? Just push the constant outside and integrate. Example, if you say integral 3x dx from 0 to 1, just push the 3 outside. This will be x power 1 dx from 0 to 1. This is looking like x power n ka formula. So 3 into x power 1 plus 1 by 1 plus 1. Limits will go from 0 to 1. This will be 3 by 2. X square, limits are 0 to 1. This is 3 by 2. Substitute 1 first, 1 square. Substitute 0 square and subtract them. 3 by 2. Clear? Second thing, if you have 2 functions, f of x plus or minus g of x into dx, you can simply separate them out, integral f of x dx plus or minus integral g of x dx. So, example, if you give me something like sin x plus cos x ka integral, then I can integrate this thing as integral sin x dx integral cos x dx. Sin ka integral is minus cos x. So be careful, differential of sin is plus cos x. This will be 0 to 90. This will be sin x 0 to 90. So when you put the limits here, minus cos 90 minus cos 0 sin 90 minus sin 0. Substitute the values. Cos 90 is 0 and sin 0 is 0. So this guy will be 1 plus 1, which is 2. That's it. We only use these two identities. We have product rule, but we don't need in physics. We don't have division rule. We don't have chain rule. So for physics, that 5 formulas and these two identities, we can handle everything that integration is required. Now we have 1 or 2 more methods called substitution methods, but we will see them in the end. When we differentiate f of g of x, then it is equivalent to and that is for differentiation, Srihari. You can't do this for integration. There is nothing like that.
Sir, sir, when we differentiate it, sir, so we'll get integration of, sir, when we do it, sir, it reduces to integration of f of g of x with respect to x, sir.
Right.
Sir, so am I correct, sir? Can we use this?
Yeah, वो तो वही करते हैं ना. Chain rule we do that only. When you differentiate with respect to g of x, yeah, then you'll get only different of you can say that way. We are doing something like that only. First you differentiate with g of x and then you differentiate g of x separately. Yeah.
Yes, sir.
Same thing. What you're saying is right. Is this clear, everyone? Copied everything? So let me give you some questions. So you try this. Let's get used to these formulas and then we will see applications. So integral root x dx 0 to 1. Get it? One by 2 root x dx from 1 to 2. Integral sine 3x dx from 0 to pi by 6. Integral cos 2x from 0 to 90. Integral x square plus 1 whole square from 0 to 1. Integral e power 2x dx from 0 to 1. Integral sine square x dx from 0 to pi by 2. Integral cos square dx from 0 to pi. If you ask me, the 7th one and 8th one are important. They come a lot. Integral dx by 3x plus 2, 0 to 1. There, let's get this right. Finish it off. When I show you, you can verify your answers. Try. Yeah, it's all straightforward formula substitutions. There's nothing to think here.
Sir, can integration come negative?
Yeah.
Sir, but area can't be negative, right?
It makes sense. Now think of like this. What if the
मतलब
curve is going bigger?
negative
So you have a
नीचे हो.
negative y coordinate. Yeah.
हाँ. सर तो हमें कैसे समझेगा कि वो एक्स एक्स मतलब वाई एक्सिस के यहाँ पे है वहाँ पे
The
लेफ्ट और
functions will
राइट
take care of it. You don't worry.
साइड.
See, here I'm teaching you in terms of area, but in real life, every time you won't get areas only, na? You can get work, you can get velocities, everything. Let's see the first one. So integral root x dx is integral x power half dx. So here n is half. So the formula is x power n plus 1. So half plus 1 by half plus 1, and the limits will go from 0 to 1. So that will be 3 by 2. So we'll get 2 by 3 x power 3 by 2. Limits are 0 to 1. So substitute 1 and then substitute 0. So 2 by 3, 1 to the power of 3 by 2 minus 0. So the answer is 2 by 3. Yeah.
The fifth question, there's no dx. Doesn't mean integration होगा नहीं.
Yeah, I forgot to give. That's what it means. You need dx. Without, I know it doesn't make sense, but I forgot to give. What the next one? 1 by 2 root x. You guys can copy down the formulas questions actually. I will write down, I'll show them one after another thing. You can note down the questions because I will turn the page so you can't see the question. Try. Others keep trying. I'll show you one after another. You can verify your answers.
तो इंटीग्रेशन के अंदर एक मतलब लाइक फॉर फिफ्थ वन हमें उसको ओपन करके ब्रूट
That's
फोर्स
it. There is no
इंटीग्रेशन
other.
करना
उसका
पड़ेगा.
भाई, yeah, उसका chain rule नहीं है. Copied the questions, everyone. So look at the second one. 1 by 2 root x. Limits are 1 to 2. So half is a constant. It will come out. Integral. This will be x power minus half dx. Limits are going 1 to 2. So half. This is again x power n. Here n is minus half. So the formula is x power minus half plus 1 by minus half plus 1. Limits will go from 1 to 2. So this is half. The denominator is again half, so the 2 goes up, and that's root x. 2 will cancel. You'll end up with root 2 minus root 1. So root 2 minus 1. Check your answers. So that 2 and this 2 will cancel off. Third one is integral sine 3x dx 0 to 30 degrees. This guy is looking like integral sine ax plus b. So a ka place mein we have 3 and b ka place mein we have 0. The formula is minus 1 by a cos ax plus b. So a ka place mein substitute 1 by 3. This would be cos 3x. Limits will go from 0 to pi by 6. Minus 1 by 3. Substitute here. Cos 3 pi by 6 minus cos 0. 3 pi by 6 is pi by 2. Cos 90 is 0 and this is 1. 1 by 3. Sure. Again, there's no physics here. It's pure math, pure formula substitution and brute force solving. There's nothing to think here. Mug up the formulas, put it there and keep solving. Try. I'll give you another minute. Go ahead with 4, 5. You have till 9.
Sir,
You
what
keep
if
trying.
there is like e raised to ax plus b?
E raised to.
Ax plus b.
Can't you do something about this? What is a power m plus n?
Oh, okay, like that.
So
Got
e power b bahar aayega na, which is a constant, right? You push it
constant, yeah.
outside.
Okay.
Let's see the fourth one. Integral cos 2x dx. Limits will go from 0 to 90. Again, this guy is looking like cos ax plus b. A is equal to 2 and b is equal to 0. The formula for this thing is 1 by a sine ax plus b. 0 to 90. So that is 1 by 2 and sine ax plus b is sine 2x. Limits will go from 0 to 90. So this is half. That will be sine 2 pi by 2 and this is sine 0. This would be half sine pi and sine 0 is 0. Now this is interesting. Area became 0. You know why? If you actually try to plot this graph, a cos 2x graph looks like this. Right? And you're saying limits from 0 to 90. So when you put x is equal to 0, it comes here. X is equal to 90 gives you like this. So this area above the x-axis is a positive area. Now see, when we say area, don't think about literally area, because later on when we study stuff, right, it will not be always areas, it will be velocities and displacements. So whatever is that quantity is a positive quantity. So area above x-axis is positive area. And this thing, if you see, this is a negative area. Basically, the y coordinate is negative, isn't it? Think of like this. For both of them, x is positive, but for this guy, y is positive and this guy, y is negative. So length into breadth, you're doing a negative y into positive x. So this is a negative area below x-axis. And you can clearly see by symmetry, both the areas are equal and opposite. That's why you got a 0. What does it mean, negative area, positive area? We will talk about that in kinematics. For now, don't worry about it. But there is a thing like that, positive and negative stuff. Is this clear, everyone? You got a 0 there. Any doubts on this integration? Keep going ahead. 5, 6, 7, 8, 9. 5 is easy. You just have to expand it a plus b whole square. Try. Everyone should try. Anyone finished everything? 7 and 8 are good. Okay. Let's see others. Fifth one, what do we do? integral x square plus 1 whole square dx. Limits are 0 to 1. Just expand this. This will be x power 4 plus 2x square plus 1 into dx. This is x power 4 dx. 2 will come out, integral x square dx plus integral 1 into dx. Remember, 1 can be written as x power 0. So this is x power 5 by 5. Limits are 0 to 1. This is 2 into x cube by 3. 0 to 1. That is x power 0 plus 1 by 0 plus 1. 0 to 1. So integral dx is x basically. This is 1 by 5 minus 0. This is 2 by 3, 1 minus 0. This is 1 minus 0. So 1 by 5 plus 2 by 3 plus 1. How much is this? 3 plus 10, 13 by 15. 13 plus 15, 28 by 15. Anyone got this?
Yeah, sir.
So next time you can remember this, integral dx is x only directly. Any doubts on this? This is still easy. It is like still x power n only. How e power 2x? That is also easy. So this guy is looking like e power ax dx. A is 2, so the formula is 1 by a e power ax. Be careful here. E power 0 is not 0. This is e power 2 minus e power 0. This is e square minus 1 by 2. You can leave the answer like that. No need to simplify it further. Most common mistake people at e power 0 is 0. So people do that mistake, simple thing, but be careful. Clear with this? The 7th one. So listen how to do these things in case you couldn't figure it out. Integral sine square x dx from 0 to 90. There's no direct way to do this, so we go back to basic max, the first class. Do you guys
Cos
remember how to
2x.
convert sine into cos? We have to use these things. You cannot integrate sine square and cos square, but I can integrate cos to theta. This is what I said, that thing will start popping up. So you can write sine square x is 1 minus cos 2x by 2. This we saw in trigonometry. So substitute here. So this will be integral 1 minus cos 2x by 2. 0 to pi by 2. So the half comes out. So just push it out. Integral. There's a dx also. So integral dx minus integral cos 2x dx. Limits will go from 0 to 90 to 0 to 90. So this will be half into integral dx is x. Limits will go from 0 to 90. What is integral cos 2x? Integral cos 2x dx is minus 1 by 2 sine 2x. So I can substitute that minus half sine 2x. Limits will go from 0 to 90.
Plus
this
1
will
by
be
2, right? Cos.
cos ka, sorry, plus the. See, that those silly mistakes happen. But luckily, I would have been lucky actually, because that term would be 0. Still, it's a mistake. So substitute the value there. That will be sine 2 pi by 2 becomes sine pi minus sine 0. Sine pi is 0. Sine 0 is 0. So you end up with pi by 4. Check, that's your answer. You know, how will the graph look like? Y is equal to sine square x. This will never be negative. So the graph actually looks like a jumping frog. So you are asking to find this area. This area is pi by 4. This is a graph for y is equal to sine square x. So take a sine x function and square it. Is this clear how to do? Now, same thing can you do for cos square x? Cos square x limits from 0 to pi. Try, I'll give you a minute. Same thing. Actually, it is the same thing. Only the limits will change. Try. So see this thing, right? So this will be cos square x, 0 to pi. This will be 1 plus cos 2x. This will be plus. This will be pi. Limits will change everywhere.
What is ln of 2?
Ln 2 only, let's leave it like that.
Okay.
This guy will be sine 2 pi. Interestingly, this is also 0 and this will be pi by 2. So the integration is the entire same only. But यहाँ पे instead of minus you get a plus now. Clear everyone? So sine square, cos square integration will look same. You know why the integration looks same? If you actually plot cos square x graph, this graph looks like this. Can you see the symmetry? It is the same thing. Sine square x graph only pushed a little to the side. So now you're finding area up to this point. So obviously you're getting double of that sine square x ka answer. This 7 and 8 are quite important. Comes a lot. You will see this integration, I think, at least another 7-8 times. So whenever you see this, remember this is how you handle this. Play with this. Let's see the ninth one. Dx by 3x plus 2. This guy looks like ax plus b. A is 3 and b is 2. So the integration is 1 by a ln ax plus b. So 1 by 3 ln 3x plus 2 limits will go from 0 to 1. Substitute 1, we get ln 3 plus 2, ln 5. Substitute 0, we get ln 2. Now, you must have learned in ln. So if you have ln a plus ln b, it's ln ab. They will teach you in max, but for now, at least remember these things. If you have ln A minus ln B, it's ln A by B. If you have something like ln A power n, this is n into ln A. So this can be written as 1 by 3 ln A minus B is ln 5 by 2. You can leave the answer like this. Because in the exam, options will be like this only. They will simplify this ln 5 minus ln 2 to this form. You should know that much, ln A plus B and ln A minus B. And Max may have a full chapter on logarithms. They will teach you then. But for now, at least understand this much. Clear with this? There. If you can handle this much integration, you know how to integrate. Unlike differentiation, right? We really don't have too much high levels and all. There is, we don't need it. Clear with this? Any doubts on this? Take a small break, come back in 5 minutes.
Sir?
Yeah.
Okay, so I wanted to ask you something, Ki. I was revising and studying for vectors again for the test, and I gave the test, but I still find that I'm not able to do the questions अच्छे से. Like if you throw,
Meaning after the exam, are you able to solve the paper again?
I'll attempt it again. I did not have the time to do it
Do
because I
that, na? Yeah,
had
yeah.
the
Do it that
class.
way. Then you will know na, what went wrong.
Yeah, no, but then even the worksheets you gave it, I was having a hard time solving those two. So like, do you
That
have?
is fine, na? So it will take time. So after the class, you can ask me what you didn't understand. I'll help you with your doubts.
Okay, yeah, all right.
That is the
I'll
thing, na? You
reattempt.
try it and
Uh,
reattempt, and whatever you're not getting, send me what you didn't get. At
okay,
least I can give
I'll
you a hint and you can try.
yeah, I'll reattempt both of the things and then ask.
Yeah, yeah. And ask me on Thursday, no issue.
Okay, thank you, sir.
Chalo, come back in 3-4 minutes.
Sir, Sir, did you see what I sent in WhatsApp, sir?
Chalo, let's start off. So let's say if I ask you a question like this. Again, this is more of a max question, but yeah, let's try one. Find area enclosed by the curve y is equal to x and y is equal to x square. That's it. Question will be like this only. So if I actually try to draw this, others, switch on your cams. Let me give you a picture how it would look. So if you draw y is equal to x, it is a line passing through the origin. And if you draw y is equal to x square, it is a curve which is going like this. Now what is being asked is find the area enclosed by the curve. That means this part ka area. You're getting what it is? So it is like a sandwich between both the curves. I want you to find this area ka answer, the black one. You're getting what is being asked? Let's see. Right, Shreyansh. How will you approach this? It might look a little overwhelming, but just ask yourself like this. So can I do something like this? So this thing, this is nothing but, I will take only the green one. And what is this point of intersection? This point of intersection is 1, 1, isn't it? And 0, 0. So I will find the area from 1, 1. This area, let's call it A1. And I will subtract up to 1, 1. This part, I will find the area under this guy. Let's call it A2. So can I say the area enclosed is A1 minus A2? Did you see what did I do? I found the area between this triangle and I found this area below this curve, if I subtract this, won't I get that piece left out? And what is area under the curve formula? So A1 is nothing but integral x into dx 0 to 1 minus integral, this is x square dx 0 to 1, isn't it? What is area under the curve? Integral function. So this function is y is equal to x. And we know area is nothing but integral y dx or f of dx. So this is the area enclosed. That thing is still a straight line. You could have still found it easily. So this guy will be x square by 2, limit 0 to 1. This is x cubed by 3, limit 0 to 1. So this guy will be half minus 1 by 3, and this is 1 by 6. Yeah.
So can you explain again this, please?
You switch on your cam, no? Why do you keep switching it off, right?
Sir, I just came now from the break.
You went out in the rain.
No, sir.
Okay, you just said something bomb rain karke. ठीक है.
No, sir. Can you please explain this one again?
You didn't listen to the question only.
Yes, sir.
And then लुको ना लास्ट में देखते हैं अभी सबका क्वेश्चन खत्म हो गया मूवी के एंड में आके you're asking what is the movie का story. My sister used to do that. We used to go to a movie when we were in school. Na? She used to start when the movie starts. She used to sleep. She used to wake up in the break so that she can eat that samosa and cold drink and everything. She used to sleep again. Last half an hour, she used to wake up and ask what is happening. I said, "Chup raho, to soch raho wapas." That is only better for her. Listen, I'll just tell you. See, we have one curve here. Y is equal to x and y is equal to x square. So the question is find the area enclosed by the curve. So y is equal to x is this, y is equal to x square is this. I want you to find the area, this part, the shaded area. Got it? So what we are trying to do is we will try to find the area under the straight line that will give you this triangle. I'll find the area under this curve that will give me this thing. If I subtract these two, won't I get the area enclosed? That's what we did. So we found the area under the straight line, which is integral x dx, area under the curve x square dx. Subtract them, you get area enclosed. All clear with this? There. Now, the most important part. The whole integration is what we're doing is for this thing, areas and volumes. No, exactly area and volumes are not important. The important part is how did we choose an element to get this? So what you're going to learn right now, when it comes again, I'll show you, right? But I think the first time you'll encounter this thing is in a chapter called Center of Mass. That's like 5 to 6 chapters later on. So the important thing, right, for every shape, there's a particular way of choosing an element and used to integrate. So let me show you one. Let's start with a disk. And this is important. Matlab, even in your HSC board exams or your CBSE exams, you have integrations and derivations. So let's say I have a disk of radius r. I want to find the area. We all know the area, right, as pi r square, but I want to find it. So how do we do this? So remember, whenever you see a disk in any question, the elements we choose are rings with small thickness. I'll tell you what it means. So listen carefully to these things. So how do I find the area of this thing? So when you have a disk, consider a ring of radius x with thickness dx. Again, remember dx means very, very small. So from the center at a distance x, consider a ring here with the thickness dx. So if I take out this ring here, Did you ever cut an onion? Kabhi dekha? When you cut an onion like a disc, can you see the rings inside? If you see an onion sometimes, doesn't it look like this rings inside like this? Or when you cut a tree, can you see the rings? Tree ka rings. So this is x and this thickness is dx. Now take a scissor and cut it. And open this. When you open this, you get a shape something like this. You'll actually get a trapezium. But this is so thin, you can almost assume it to be like a rectangle. So if you take this outer circumference, what will be the circumference of this thin ring? 2 pi
2
x.
pi.
So this length will be 2 pi x. And this thickness will be dx. So you have created a small rectangle. So dA is the area of this thin rectangle or area of the thin strip. Both are equal. So basically we are ignoring the small edges. That is the whole point of integration. You take the thickness so small, the error can be neglected. This is the area of that thin rectangle or area of the thin strip. Both are the same thing. So we got area of this thing is length into breadth, which is 2 pi x into dx. This is the area of the thin ring. Now you want to find the area of the disk. So if I add all these rings, won't I get the full disk? What do you mean by add all the rings? Integration. So the area of the disk will be integral dA. Tell me one thing, where is the first ring starting from? Where is the first ring starting from? From the center, isn't it? A very
0.
negligible ring. So you're starting from x is equal to 0. Where is the last ring ending at? X is equal to r. You're getting the meaning of it? So when you take x is equal to 0, you're taking a small ring at the center. X is equal to r by 3, this is the ring. R by 4, 2r by 3, r by 2, 3r by 4, all these are rings. So by changing different values of x, I'm getting different rings. So all the rings are going from 0 to r. That is the meaning of limits. Your rings are going from where to where. Now substitute the value. This is 2 pi x into dx from 0 to r. 2 pi is a constant, it comes out. Integral x power 1 dx 0 to r. X power 1 dx is x square by 2. Limits from 0 to r. 2 will cancel. We get area is equal to pi r square. Isn't that the area of a disk? So I have taken a thin rectangle and add all the rectangles. I got area of the disk. Now, again, exam they won't ask like this. There's a purpose for this, but this is how you approach whenever you find area of the ring. Have a look at the steps how we did this, and let me show you how they can ask a problem on this.
Could you go to the previous page, sir? Oh, yeah, okay.
Again, don't worry too much about this. Understand, grasp as much as possible, because when these things actually come again in physics, I'll show you then again. But the thing is, you should have an idea. Because later on, when they come for the first time and you learn at that time, the concepts are already hard. This will be one more additional thing. But this is how we actually use integration. So where do we use this? So listen, let me show you an example. How do we use this? Let's say someone manufactured a disk, which is a non-uniform disk. So we will define something called sigma. Sigma is mass per unit area. Meaning, example, say, if someone tells you sigma is 3 kg per meter square, Meaning if you take 1 meter square ka sheet, it has a mass of 3 kgs. That is the meaning of that. So if let's say if you take a rubber sheet or a plastic sheet, if you take 1 meter square ka sheet, has mass of 3 kg. In school, right, you studied rho. That is a volume density, kg per meter cube, isn't it? So sigma is kg per meter square. The weight of a plastic sheet, the weight of a copper sheet, something like that. You're talking about areas. R is the radius. Now this sheet is, this disk, right, is a little weird. It's not a uniform disk. The sigma is given by, let's say, some number 2 into x. I'll tell you what it means. X ka value is less than equal to R. So the meaning of this, you know what? And x is the radial distance from center. Let's say R is the radius, which is 2 meters. Now see, what is the meaning of this? When I put x is equal to 0, what is sigma? 0, right? So the meaning of this is, let me show you this data in the next page. Let's try to understand this whole thing. But did you get something here? R is the radius. What is sigma? We'll talk about it. So sigma is 2 into x for x less than R to 0. Look at the meaning of this. When I put x is equal to 0, it is 0. That means there is no mass only. So there is no mass at the center. It is pretty light. If I put x is equal to 1, the mass will increase a bit. If you put x is equal to next number, it will increase more. As you keep going out, the mass is becoming heavier and heavier and heavier. Can you think of a disk like this? Imagine like this. Someone made a disk inside with thermocol, then they made with wood, then they made with copper, then they made with steel. So you made a disk with variable materials. You're getting it? So as you go out, the mass is increasing more and more. That is the meaning of this function. As we go away from center, x is increasing, so mass is increasing. So 2x kg per meter square. So you made a disk like this, where whose mass is not uniform everywhere. It's a non-uniform disk. So all these points will have some density. All these points on this circle will have more mass. Maybe it's a different material. Maybe you're using some metal, copper or something. The edges will have even more mass. Maybe used lead. Think about it. If you take your cycle car tire, is it uniform disc? The edge of the tire is rubber. And then you have a rim. Then you have spokes. Your whole tire, if you see, it's a non-uniform, isn't it? You see your car ka wheel. The center of the wheel is made of metal and the outside is made of rubber. So car ka wheel is reverse. Center mein it is more weight and outside it decreases. Isn't it? Are you guys able to see this picture there? Now, if I ask you this question, find the mass of this disk. If I ask you find the mass of the disk, we have a problem. Why? See, suppose if you give me simply sigma is 2 kg per meter square. Matlab sigma is constant everywhere. And if you tell me radius is r, mass is simply sigma into area. Do you agree with this? Because every 1 meter square is 2 kg constant and area of the disk is pi r square. If I multiply into 2, I will get the mass of the disk. Isn't it? But my problem now here is at every point the mass is changing. So how can I simply multiply, sigma into area? What will I take sigma? Will I take the sigma in the center? Will I take sigma in the middle or this guy or this guy? Which one should I take? Do you get in the problem? Doesn't this problem look similar to when I want to find area under the curve? What will I take the y coordinate, isn't it? Are you getting the context here? What is happening? Since the disk mass is different at different points, I cannot simply say sigma into area. This will not give me the answer, because fine, area I know, but sigma I'll take which sigma? Should I take the one in the middle? Should I take the one in the outside? Which one? Is this making sense? So how do we approach this problem? So listen carefully. I'll show you this and I'll give you one more like this. So we have sigma is equal to 2x and x is less than r. And radius is given actually. R is 2 meters. Perfect. So how do we do this problem? Same story. The moment you see a disk, you choose an element at a distance x. Choose an element of thickness dx. Now this element is so thin. Now can I use the concept that sigma is almost constant for this thin slice? That is the whole story of integration. Dx is so small. We can assume the density is almost constant for this. Cut it here. Open this. This will be 2 pi r, 2 pi x. So till here it is a story, same story, dx. So dA, the area of this thin ring, is length into breadth, 2 pi x into dx. Nothing changed so far. Now, the mass of this thin ring, let's call it dm. So dm is the mass of this thin ring. Now you need to understand the only formula I know is mass into area, density into area. The problem I faced till now was the density was changing everywhere. So now what am I saying? The thickness is so small, I can assume the density is almost constant. So this will be sigma into dA. Since dx is so small, we can assume sigma is constant for the dx thickness. Just like we assumed y is same for the dx thickness in a rectangle. Clear? Now what is sigma? Sigma is 2x. What is dA? 2 pi x dx. So we are done there. So we got the mass of the thin ring dm is 2x into 2 pi x dx. So you want the mass of the disk. So what to do? Add all the rings dm. Where are the rings starting from? Rings are starting from 0 to r. R is the value is 2. So this will be 0 to 2, 4 pi x square dx. 4 pi will come out. X square dx ka integral is x cube by 3, x power n plus 1 by n plus 1. Substitute the values here. 4 pi. This will be 2 cube by 3 minus 0. 2 cube will be how much? 8, 8 fours, 32 pi by 3 kgs.
So why does this look like a sphere?
Because looks like a sphere. It's a disk only, Ray. How will I draw a sphere on 3D in a paper,
No,
right?
no, sir. The formula which we got after integration.
That thing, it just came randomly.
Okay.
बस चेंज कर ले 2x स्क्वायर कर लेना चला गया ना तेरा फॉर्मूला.
I mean, do we find the volume of sphere using this method?
आएगा बाद में वो भी है. But did you guys understood what did I do? Again, look at the context. The disk ka mass is changing everywhere. I can't directly say sigma into area. So what did I do? The same way. The curve ka y coordinate is changing everywhere. So I can't say y into x. So what did I do? I took a small slice. So here I took a small ring. Then I said, this thing is so small, this y coordinate, technically speaking, it looks like this. I said, you can ignore this piece here. I did the same thing. I said sigma is so small, you can assume the sigma is constant here. So here the area was y into dx. Here the mass was sigma into area. Then I said integrate this, I'll get the total mass. Is the concept clear, everyone? These are really tough ones. Even your seniors have a problem with this. If you see, the integration is very easy. X power n integration. The headache was getting the whole elements.
Sir, can you explain that area of thin ring and mass part again?
The area of the thin ring kya hoga? When you cut this, what do you get? The circumference is 2 pi x. Na? What is the circumference of this ring?
2 pi x.
2 pi x. What is the thickness? Dx. So what is the area? Length into breadth.
Okay.
So what is area into sigma? Sigma is what? Sigma is 2x kg per
Mass
meter
per
square,
unit
na?
area. Yeah.
Yeah.
So you
So if you
multiply that
multiply
area.
area, तो mass आ जाएगा.
Okay.
If you do kg per meter square into meter square will go off. You'll get kg left out. All clear with this? So I'll give you one more like this now. You guys try and give me the answer. So we have a disk. Sigma is given by, let's say, 2 minus 5 minus x, where x ka value lies between 5 to 0. Now look at this disk, it is different. If I put x is equal to 0, it is heavy in the center. As you go outside, it becomes lighter, and the outermost is almost 0. Means someone made the center with heavy metal, then they made with little wood, then they made it with thermocol maybe on the outside. So this disk mass is decreasing as you go outside. So the radius is 5 meters. Sigma is your, this is called mass density. So 5 minus x kg per meter square. Find the mass of the disk. So this is what we use integrations for. When you have to deal with shapes or things, where the density is not uniform, we need to use integration. You can't use the straightforward formulas. And real life, you see a lot of things like this. Your cycle ka tire, your car ka tire. You want to use reference, you can just use this. How did I do? How did I start the whole thing? Take a thin ring area. So till here, now the story is always the same. Up to the area, but the story is always the same. Area into sigma will give you a mass, and then integrate the mass, you'll get the total disk. You can just copy down that sigma 5 minus x, and then you can use this and solve. Try. Use this page as a reference and solve. Exact same thing. You just have to substitute the formula. Hmm. 25 pi by 3. Anyone else got an answer? 125 pi by 3. I think most of you are getting it. Let's see, same story. Take a disk, get a distance x. Consider a thin ring dx. So cut open this, you will get a rectangle. So repetitive story. I know for the first time it might be difficult, you will get used to this. So this will be 2 pi x. This will be dx. So basically you made a ring into a rectangle. The area of this thin ring is length into breadth 2 pi x into dx. It is given sigma is 5 minus x kg per meter square. So for this thin ring, the mass will be dm. This is the mass of that ring, will be sigma into area of the ring. Sigma is 5 minus x into 2 pi x dx. So for that ring, this is the mass of it. So if you want the mass of that disk, I have to add all the rings. Adding meaning integral. And the rings are starting from where? That is the meaning of limits. Where are you starting and where are you ending? You're starting at x is equal to 0 and you're ending at x is equal to 5. So your limits are going from 0 to 5. So when you put x is equal to 0, you're taking the ring at the center, which is a point. And when you take x is equal to 5, you're taking the ring at the outermost one. This will be 2 pi into 5 minus x into x dx from 0 to 5. So take out that 2 pi common. Then you'll get 5x dx minus integral x square dx. Limits will be 0 to 5 and 0 to 5. So this will be 2 pi 5, that would be x square by 2. 0 to 5, x square dx is x cubed by 3. 0 to 5. Substitute the values here. 2 pi 5 by 2 into 5 square minus 0 minus 1 by 3 5 cube minus 0. That is 5 cube by 2 minus 5 cube by 3. That is 5 cube by 6. So 2 pi into 5 cube by 6. That's 125 by 3 kgs. You can leave the answer like this. So the thing is, once you have written this part, dm of the ring is this. Physics got over there. Then it is just integration. It is an x power n integration. I know we did the integration today, but yeah, x power n. So definitely make sure to revise all this stuff once. Clear with this? You can find area of a disk without integration. You could have done that in school also. But let's have a look at this. I'll show you that also once. Any doubts on this page? But you're getting how we use integration now. So till now, we didn't know how to find area under a curve, and we didn't know if some disk is having a variable mass, we don't know how to find. But using integration now, we are able to figure out. So there is a neat trick to find area of a thing. Look at this. So if you have a disk, cut this into thin rings. Like an onion. So if you take all these thin rings, right, and if you put all the rings together, what you will notice? You will notice all the rings, when you keep them one on top of another, take the ring, cut them and open them. So this center will be this point, agreed? and this outermost circle will be the largest ring. Will that be this thing, isn't it? How much is this? 2 pi r. So from the center to this ring, what is this distance? R. So what is this distance? R. What is the area of a triangle? Half base into height. So half base into height, pi r square. Isn't that the area of the disk? Making sense? So if you actually cut a disk into thin rings and place them, you will actually form a triangle whose base will be the circumference and the height will be the radius. Making sense, everyone? There, you can do this actually without even integration also. That's a neat trick to find out. So, but the main idea is that you have to make it thin things. Any doubts on this stuff? So check out this. We started integration today only. I know there's a lot of things to there. I'll send you a small practice sheet also on this formulas and everything. So do practice a bit, especially get used to the integration of formulas. That is important. So these areas and elements, right? Try to absorb as much as possible. I'm sure you're understanding, but I know it feels a little overwhelming suddenly, like, that is okay. Because next class when we catch up, we will do more problems. We'll do even more deadly ones. So this will feel easy. Getting it? So let's say your hand is paining. Let's say your finger is paining. How to get rid of it? Take a needle and poke your hand. That hurts more. So you'll forget about the finger. So that is a concept we are going to use. So next class, we are going to do more weird shapes. We are going to find volume of something like this and everything. The next class will be important. We'll do more shapes, more elements, and then we'll continue from there. Okay, so that would be the last one for the day. So to revise this. And last week I have given you a few sheets. Hope everyone has tried that. Let's see any doubts in that sheets first.